A query comes back wrong in production. You check the logs. There are no logs. Did the retriever return the wrong chunks? Did the language model ignore the context? Did the hallucination guard fail? Without observability, you are debugging blind. In this episode, we add a tracing layer to the full pipeline, so every query records what was retrieved, how long each stage took, how many tokens were used, and what the final answer was. There are 6 things worth observing on every query. Which chunks were retrieved and how similar they were to the query. The latency of each stage independently, so you know whether slowness is coming from retrieval, the language model, or the hallucination guard. The input and output token counts for cost tracking. Whether the answer was served from cache or freshly generated. Whether the hallucination guard passed or failed. And the full text of the final answer. Together, these 6 data points let you diagnose almost any production failure. LangChain has a callback system that fires events at each stage of the pipeline. We can hook into these events by subclassing the base callback handler class and overriding the methods we care about. OnRetriever start fires when a retrieval query is about to run. OnRetriever end fires when the chunks have been returned. OnLLM start fires when the prompt is about to be sent. OnLLM end fires when the response arrives. We record timing and data at each event to build a complete trace. Our RAG tracer subclasses base callback handler. We initialize a trace dictionary that will accumulate all observations for the current query, and a stage start dictionary for timing. On retriever start, we store the query text and record the current time. On retriever end, we compute elapsed time in milliseconds and store it in the trace. We follow the same pattern for every stage we want to time. We extend on retriever end to also log the retrieved chunks. For each document, we record the source file name, the page number, and the character length of the chunk. This tells us exactly which parts of which documents were passed to the language model on this query. When an answer is wrong, we can inspect this field immediately and see whether the right chunks were retrieved. If the right source is missing from this list, the problem is retrieval. If it is present, the problem is generation. We count tokens using TickToken, OpenAI's tokenizer library. On LLM start, we encode all prompt strings and sum the token counts to get total input tokens. On LLM end, we encode the response text to get output token count and record language model latency. Input tokens multiplied by the per token price gives you the cost of the prompt. Output tokens multiplied by the output price gives you the cost of generation. Summing these across queries gives you daily and monthly cost tracking. We write structured logs to a JSON file, 1 JSON object per line. This format is easy to ingest into any log analysis tool, including Elasticsearch, Datadog, or Simple Pandas data frame. On chain end, we store the final answer and a UTC timestamp. The trace dictionary now contains every field we care about for this query. The next step is to flush it to disk. The flush method serializes the trace dictionary to JSON and writes it to the log file, then resets both dictionaries for the next query. We attach the tracer to the chain by passing it in the config callbacks list. LangChain automatically calls the handler methods at each stage. After invoke returns, we call flush to write the complete trace. In production, you would call flush inside a try finally block to ensure the trace is written even if the chain raises an exception. You now have a full observability layer built from scratch. Every query records which chunks were retrieved, how long each stage took, how many tokens were consumed, and the final answer, all written to a structured JSON L log. In the next episode, we look at purpose-built tools. LangSmith and Arise Phoenix give you everything we built here, plus a visual interface, automatic evaluations, and team collaboration. Subscribe so you do not miss it. See you in the next one.